let's take our let's take another step. How like neural network helping in our daily questions, like you ask ChatGPT like how I will perform this, can I go this. So the basic thing is neural networks give you output according to some probability, like what is the probability of output this, and if some output has a higher probability, they just return it. So for basic example, let's say we have asked a question, will I pass this class. So for this we have few features. We can consider them as an inputs of our neural network. First input is x1, the number of lectures we are going to attend, and then the second input is number of hours we have spent on our final projects. So these are two features which are going to rely on whether you are going to pass a class or not. So let's see. So as you can see, we have a graph. So this graph, this line x-axis shows the number of lectures you have attended and the number of hours you have spent on your projects. And the greater the both, the more the probability will be that you will pass the exam. But if both are less, then there are higher chances you are not going to pass an exam. There are few exceptions, that you have given the you have attended less number of lectures, but you have given a large number of hours in final projects, or you have given less hours in project but you have attended almost all the lectures. So these are the exceptions. So without knowing any concepts on neural network, even if I ask you where you going to draw a line to build a model where it can predict that whether you're going to pass or not, most probably you are going to build like this. And this is very simple. You're going to build a line this, if something is here, it is not, the student is not going to pass. If something is here, student going to pass. So how we are going to apply? Let's say we have an input. This is, let's say we have our neural network, and we have asked for this. Now this neural network is not trained. So for this we have given input 4 and 5. It like calculates on it, add like multiplied with the weights, add bias, applied activation, and we have an output. And what we have output 0.1. On looking at the graph, anyone can say that this person with 4 and 5 going to pass the class. But why then here model predict 0.1 probability? It should be like 0.89 or something. Then why? Because this neural network model is not trained. Like it doesn't have any data or weights to which is so it actually is not trained model. So how it is going to predict it? So this is where the concept comes loss. So what we do is we first capture the first response of our model. So the response, the predicted output is 0.1. With the graph, as we saw that the probability for passing the exam was 1, like almost 1. It is not completely 1, it may be like 0.999 something. So let's say right now it is 1. So the probability that the student going to pass, we have actual data output is 1, but the predict is at 1. So we have, there is a concept called loss, where you calculate what is the difference. So there are a lot of methods, functions to calculate loss. The one is the difference, where you calculate. So here the loss is 0.9. So now quantifying loss, so you can calculate the loss by using few things, like there are few function RMS, then mean empirical loss, there must be a binary cross entropy loss, and mean squared RMS same. So there are few methods to calculate the loss, and the loss should be less minimum for better performance of our model. So the lesser the loss will be of a model, the more the optimized and the output will be better and quality. And that's why we see that somewhere we see that a model have a loss of 0.1 or something, then we can say that model is okay, because 0.1 loss is still a very big number out of 1. So the model loss should be like 0.05 something, then and only it is considered better model, because loss should be very less for better predictions. So let's say we have all these sets. So as you can see, we have sets of students with some inputs, like a student with the 4 5 4 hours in lectures, number of hours in projects, 4 5. Someone is 2 with 2 and 1, someone with 5 and 8. And we have an fx, the predicted output with the neural network, and the y, which is the output we have noticed. So let's say we have 4 5. 4, the student with the 4 5 should be passed, and that's why the actual is 1, but the predicted is 0.5. So we will give neural network let's say comment type, that we will what we say, हम उसे कमेंट की तरह देंगे एंड एज अ फीडबैक की तरह देंगे कि नहीं तुम गलत हो, बिकॉज इट इज़ वेरी फार फ्रॉम द एक्चुअल इनपुट. We have 0.8 chances for 2 and 1, but this is what 0.8 what predicted by the model, but what is the actual thing? 0, because 2 and 1 is very less, and it is going to be it is has higher chances of failing, and that's why the actual output is 0, but the predict is 0. And then again we will give a feedback of false to a neural network. Now with 5 and 8 we have an predicted output 0.6, and we have an actual output 1, so it is closely to which is the actual output, and that's why we will give feedback of true to our neural network, and we will know what are these feedbacks and how it is going to favor our model. So right now you have to understand that we are going to give feedbacks to a neural network according to looking the loss between predicted output and the actual output. There are a lot of ways to calculate losses. As we already see, we have empirical loss. We already saw that we have different types of methods and functions to calculate our loss. You don't have to go more right now in the deeper why we use these, because all the functions have different use cases according to different models. For this, most used most of the time, and most initially you should know, like there is a mean squared error loss function where you calculate the mean distance between these two. Let's say here the distance between 1930 is high, that's why the loss will be high, and that's why we are going to return false. 2080 is high, but 95 and 85 have less distance between them, and that's why we are going to return that it is true and it has predicted. And these are the feedbacks which is going to help our model to optimize on training time, and that's how our model get trained and gets more optimized every step. Now we are going to learn how actually training of our neural networks actually works. So let's see. Now we have to calculate loss optimization, and before that let me just tell you what are we going to do. We have a function, we give some input to it, this function returns some output y. Now we didn't like our output y, and we wanted to do some changes. Wanted some changes in y, but we can only change a. So what we are going to do is we are going to compare this predicted y, the output which is given by our function, with our y which we wanted. We are going to store our difference. Now this difference, according to this difference, because of this difference, we are going to change our input in such a way that the next time we are going to give that optimized or like a modified input, so that the y gets more closer to it. For example, let's say we give input a for some function 8, and it returns output 4, but we wanted an output 7, but we have wanted 7, we got 4. So the only thing we can change is input to get our output. So what we are going to do is we are going to compare the difference between them, which is 3. Now there is a process called backpropagation. We are going to learn more about this in further, but for now just understand that in the process of backpropagation, this 3 going to play a role in such a way that this input going to change. So let's say this input gets changed to, let's say 14. This gets to 14. So now this 14 is going to in this function, and this function returns you 7. And I hope you all already guessed it. This function nothing but a by 2 function, where you get input and gets half. So we initially get 8, and we initially gave 8 and got the input 4, output 4, and we wanted 7, so we calculated 3, and because of this 3, in the process of backpropagation our input got changed to 14, and now because of this 14 we are going to give again this to input and we got 7, and that's how our actually the training works. So now let's see what is happening here. What we do is we calculate our loss at the end of the output in forward propagation. We forward propagate from input to output, calculate our loss, compare it with our actual output which should be there, calculate our loss, and according to loss we backpropagate. Backpropagation is a process where you changes your weights. You don't change the input. I have told in the example that your input get changed, but in backpropagation actually the weights get changed, or I say optimized, and then those weights again get multiplied and get calculated with our inputs. They are again pass in forward propagation, again give you some output, you again calculate, and but in the next time there may be chances the answer will be getting closer to your actual answer, and that's how our model get trained. So let me just skip it, and this is the where thing actually comes. So what you do is, we have, let's say, in a neural network with two inputs, x1, x2, and we have single output y. We have two weights, w1 and w2. Now we want some output, we have an actual output, we have two inputs, we can't change these two. These are restricted to change because we can't change. If we are giving a model an image to get something else, we can't change input because we want output from that input only. So we can't change x1 and x2. The only thing we have is weights. So what we are going to do is calculate our process of forward propagation. I hope you all remember: multiply, add a bias, apply activation, and get your answer. Then after answer you calculate the loss, and this is the loss you get. We are going to create a graph, 3D graph with our loss function. This is the loss we got with the different values of w1 and w2. So let's say this is w1, so it is 0 and 1, and you will understand. So this is the graph where you have weight 1 for input 1, weight 2 for input 2, and because of these w1 and w2 different with the different values, you have the loss function. Now the main process in the backpropagation occurs is you calculate the change in the loss with respect to the weight. You calculate the change in your loss with respect to all the weights you have used in your neural network. So we have to calculate our change in our loss with respect to w1. We have to calculate change in loss with respect to w0, and this is how our change is going to look like. What we have to do is, now this is the graph. We have to what we have to get actually, what are our tasks? We have a aim to get the lowest loss as much as possible, and this is how we are going to get the most optimized model, trained model. So the only aim is to get a minimum loss as much as possible. For the minimum loss, as you can see, the more the blue, the better the model, because with the least loss. So the thing what we do in the next slide, you can see, we take some random values of w1 and w2. As you can see here, we take some random values for w1 and w2. Here we have seen +1. Then we will calculate change in loss with respect to all the weights. Then we find the gradient, and there is a concept called gradient descent. We will know in few moments, but with the concept of gradient descent, what you do is calculate the gradient with the least slope. Let's understand in a 2D, so it will be more intuitive. Let's say this is loss, this is only one weight because we are going in 2D, and this is our graph. So if you see, let's say we chose this randomly our weight. Now what we want is we want a loss as less as possible. So we are going to calculate a gradient, and at this position we are going to calculate our loss. Now where should we move? We should move here or here. As you already understood, we have to move in a way where loss are going to get as less as possible, and that's why we are going to move in this direction. Here we are going to get a little less weight. The amount of the quantity of weight will decrease, and it can be different uh, graph like this. And for this your weight can increase because the only task is to decrease our loss. So here we are calculating a gradient, and then are changing our weight according in such a way that our loss should get less. So here we have got lesser loss. So the thing we are doing is key, we have to randomly select points for weights. We will select random values of weights, then we will calculate the gradient in this graph. Then we will move in direction where our loss will going to be less. This movement will be very less, but we have to move in such a direction where the loss is the very steepest, where the loss is decreasing very rapidly, and this will be the direction. As you can see here, we going to move in this direction, and in further steps we will select our value of weights. We will move in direction of lesser loss. Then at that point we will get another value, different values of weights. Then we will again forward propagate with these w1 and w2. We will get another output. We will another calculate loss. This loss will be here. We will calculate again our loss descent gradient descent. Then we will move again, and this is how proper concept of gradient descent comes, where you calculate the gradient between the loss with respect to the every weight you have used, and then changes your weight according in such a way that your loss gets decreased in every step. And that's how you change your weights, and your model get more optimized in every step. So we have a step of forward propagation, we have then loss, then backward propagation. In these three steps our model completes one cycle, and with one cycle it gets updated weights, and decrease lesser the loss. So this is the concept they have written here. I have already explained that it initializes the weight with some random values, then it compute the gradient with every weight, then update the values of weight it actually decreases, then return the weight, then again it gets in a loop where these weights are get multiplied and added up with the inputs calculated, and again we get another output, we compare it with the actual output, find loss, return it, find gradient, and these all steps run again and again. And this is what we call training process. In training process all these cycles happens. Every time our weight changes, loss decreases, and as the loss decreases the more optimized our model become. This is where you can see like how actually you can implement this in Python. So you can look at it, it's not a very big deal. Now you will be seeing like what is this term. We saw this is an old weight, this is the new weight, this is the gradient descent, this is the loss we have calculated. Now what is this? This is called learning rate. What is learning rate? Let me just show you if there is a graph. There is not. So let me just draw here. So let's see, we have this graph, we have this graph for our model, and for this model we are here, and our this is our loss function. So we want to go ahead because this is the lowest point of our graph. This is loss and w. So we are here at this loss, and we want to decrease our loss here. Now what our learning rate does is, if our learning rate is very less, so our loss going to get smaller, but because the learning rate is very small, it is going to stuck here only at the local minima. तो एक्चुअली होता क्या है कि जो लर्निंग रेट होता है उस पर डिपेंड होता है कि लाइक जो हमारा जो लॉस है वो किस तरीके से कैलकुलेट हो रहा है, और कैलकुलेट होकर हमारे वेट्स किस तरह चेंज हो रहे हैं. हमारी जो इक्वेशन थी वो ये थी, W फाइनल इक्वल्स टू W इनिशियल माइनस लर्निंग रेट एंड आर लॉस. सो अगर ये ज़्यादा होगा सो WI में और डिफरेंस आएगा. सो जो W फाइनल है वो बहुत रैपिडली डिक्रीज करेगा. सो इट कैन लाइक अभी यहाँ था, अचानक से यहाँ आ गया, फिर लेट से अचानक से यहाँ आ गया, अचानक से यहाँ आ गया. सो इट विल गेट ब्लास्ट लाइक. फिर जो न्यूरल नेटवर्क है ये ट्रेन ढंग से नहीं हो पाएगा अगर यहाँ पे हम इसको बहुत ज़्यादा स्मॉल करा. सो जो इसमें चेंजेस आ रहे होंगे वेट्स में वो इतने कम होंगे कि हमारा वेट्स है वो यहाँ से यहाँ चेंज होगा, यहाँ से यहाँ चेंज होगा, यहाँ आके बस यहाँ, और ये एक टाइम पे आके यहाँ पे अटक जाएगा. और जो यहाँ से आके अटक जाएगा, लेकिन हमारा मॉडल तो यहाँ तक ट्रेन हो सकता था, इस लॉस तक अचीव कर सकता था, लेकिन वो यहाँ पे आके अटक गया. इसका मतलब वी हैव टू सेलेक्ट आवर learning rate very carefully so that our model can work. So you have to select in such a way कि वो जो यहाँ पे सेलेक्ट होकर आया वो इतना जा सके, लॉस को मेंटेन कर सके और देन यहाँ तक आ सके. So this was the concept of learning rate. This is the same gradient descent. You calculate, you changes your weight according to it. Now back propagation जैसे कि इंट्रोड्यूस करा था, तो how it does happen. So you calculate your loss. How it does is you calculate the change in your loss with respect to a weight. Then this weight we can write the change in weight accord in terms of this, in these terms with the input terms, and with the derivatives, and with the help of derivatives, with the help of the main thing called chain rule. And because of chain rule you can calculate the gradient descents and changes in the loss with respect to all the weights. So as you can see, we first calculate change in loss with respect to W2, and with the help of chain rule we can write the change in loss with respect to the last output we got, and the change in output with respect to W2. So this is obvious that this output is affecting the loss and this weight is affecting this. So we can, with the help of chain rule, we can calculate the change in loss with respect to this W. Now similarly, as you can understand, you can comment down like what will happen for this W1, but for now we can say that with this W the change we got because of this Z1, and because of this W1 we got change in this Z1, and that's how you can calculate the same loss in the change in loss with respect to weight 1. Then for weight 1 you are going to calculate that this y1 got changed because this got changed because of y1, and this y1 got changed because of w1. So now for w1 you have to extend it. So you will extend it how? For this is what it is, w1 y w1. So इसकी जगह हमने ये लिखा है कि y फर्स्ट चेंज हुआ z1 की वजह से और z1 चेंज हुआ w1 की वजह से. So we are with the help of chain rule we are calculating what is the change in loss with respect to weight 1, and this is how we are going to calculate with the help of chain rule. ये और एक्चुअली क्या होगा, ये हर वेट के लिए काम करेगा. ये हमने जो अभी यूज़ करा ये न्यूरल नेटवर्क, वेरी बेसिक न्यूरल नेटवर्क, सिंगल न्यूरॉन सिंगल लेयर के साथ ये एक न्यूरल नेटवर्क है. सेम चीज़ हैपन होती है एक बहुत कॉम्प्लेक्स न्यूरल नेटवर्क्स में, जिसमें लैक्स ऑफ वेट्स होते हैं, लैक्स ऑफ इनपुट्स होते हैं, उन पे काम होता है. सो ये सारे मैट्रिक्स मल्टीप्लिकेशन की हेल्प से होता है, एंड दैट्स वाई तो GPUs हमें बहुत रिक्वायर्ड होते हैं लाइक फॉर दिस हैवी टास्क. इसलिए ट्रेनिंग के वक्त के लिए हमें बहुत हाई परफॉर्मिंग GPUs चाहिए होते हैं, क्योंकि ये जो टास्क है मल्टीप्लिकेशन एंड डेरिवेटिव्स हैं ये